Day 4, conversions, length, mass, and time. So here are some conversions. Length, 5,280 feet in a mile, 3 feet in a yard, 12 inches in a foot. Those are units of the English system that usually everybody's very familiar with. The conversion 2.54 centimeters is equal to 1 inch. Well, that's a conversion that some people might forget or they don't know, and that's a conversion from the English system to the metric system. 1609.34 meters is equal to 1 mile. And so, if you're active in sports, maybe you're a runner, and if you run the 1600 in a relay race, the 1600 is 1 mile. There are 2.20462 pounds in 1 kilogram. So 2.20462 pounds in 1 kilogram. Usually we do pretty good by just, taking an estimate of 2.2. But 2.20462 pounds per kilogram. 16 ounces in 1 pound. 2,000 pounds in a ton. Now, if there's 2,000 pounds in a regular ton, a metric ton, there's 220462. So basically, we just take this number, this 2.20462, and we multiply it by 1,000. So we just bring that decimal point over. And so 2204.62 pounds is a metric ton. 1,000 kilograms then would be 1 metric ton. So you just take this 1 kilogram is this, multiply it by 1,000 kilograms, 1 metric ton. That's how that works. But a standard ton is 2,000 pounds. And you should know that there's 365 days in a year, 24 hours in a day, 60 minutes in an hour, and 60 seconds in a minute, and 3,600 seconds in 1 hour. Basically, you just take 60 minutes, and each minute has 60 seconds, so 60 times 60 is 3,600 seconds in 1 hour. It's been my experience in teaching conversions that students find some conversions they find very easy, and others they find very challenging. I wanted to do, before we do these 3 examples, I'd like to do some other example. If we have, say we're going to operate an airline, and there's 200 people on the airline, and each person, so I'm going to say each people, I'm going to give 1 can of soda to each one of them. All right, and then so everybody gets 1 soda. Now, if I had a vending machine on the airplane and I had 1 soda on the airplane, if I had that vending machine, and that vending machine said that 1 soda was 50 cents, how much money would it cost to make sure that everybody got a soda? And so you would look at this problem and you'd say, well, I don't even need to write this stuff out because I can just do that in my head. It's common sense that it's going to cost the airline $100. Well, okay, good. That same logical flow is what you need to solve all of the conversion factor problems. So what happens when the airline no longer gives someone a full soda? Maybe they give the person like 6/10 of a soda. So maybe they don't, they pour it into a little cup so that you don't get a full soda. Maybe you just get 6/10 of a soda. Soda still costs the same amount of money, but how much does it cost the airline now? And so it's going to cost the airline $60. And so because you take 200 times 0.6 times 0.5, and so it's going to cost the airline less. So the airline's going to save money. That's really good for shareholders in the airline. Not so good for the people necessarily, but I think the reason they did that is because the that they were finding that they were wasting soda on the airline, and so they don't give typically a full can of soda to each passenger anymore. But what if what if we change the price? Instead of 50 cents a soda, why don't we charge $1? In this case, if we charged $1 per soda, right now 200 times zero point 0.6, that's 120, and so 120 times 1, that'd be $120. All right. So I realize you can probably do these calculations in your head. So I wanted you to be able to write it out in brackets because it'd be a lot easier to solve your conversion factor formula questions writing it out in bracket notation. We want to take 8 kilometers and we want to go into feet. Well, in each kilometer, there are 1,000 meters. Notice that the kilometers drop out. Now, we know that 100 centimeters in a meter. We learned that from the metric system. And I had to write the bracket this way. The meters had to be in the denominator so they can cancel. And we're wanting to go not to centimeters, we want to go to feet. So there's 2.54 centimeters, that's our English to metric conversion. 2.54 centimeters is 1 inch. And we're almost home because we have to do 12 inches in 1 foot. Okay, good. So the centimeters are drop out and the inches go out, and I'm left with units of feet. So now all we have to do is calculate it out. I like to do this is the way I like to enter it. I say 8, and then I hit the times, 1,000 multiplied by 100 divided by 2.54 divided by 12. And I get 26246.7, and then let me write it out here. 26246.7, and then 1916 feet. So I can bring that decimal point over once, twice, 3 times, 4 times, and I get 2.62 times 10 to the 1, 2, 3, 4 times 10 to the 4 feet, which is what we got up here as our answer. 500 pounds, and I have to determine how many kilograms. So we start off with what we know, 500 pounds. What's the mass to weight conversion? There are 2.20462 pounds in 1 kilogram. See? 2.20462 pounds in a kilogram. Looks like I forgot the 2 right there. So 500 pounds, the pounds drop out. So I take 500 divided by 2.20462. And I get roughly 227 pounds. Or excuse me, kilograms. 227 kilograms. See, it has to have units of kilograms. The pounds dropped out. So I have 7.45 times 10 to the 4th seconds. And what I'd like to do is convert this into hours. Well, there are 60 seconds in a minute, and there are 60 minutes in an hour. So notice that the seconds drop out and the minutes drop out, and I'll be left with units of hours. So 7.45 to the 4th, and I have to divide that by 60 and divide it by 60 again. and I get 20.7 hours. Now, these conversions require you, in order to do them, you need to know all of these conversion factors. If you don't know the conversion factors, it's impossible. It really is. It's impossible to get the right answer. You have to know those. So you're going to need to memorize these for your homework and your quiz. So make sure that you know all of the conversion factors. What I'd like to do is I'd like to do a quick problem that has more steps than what you've seen. So let's say I have 525 meters and I want to know how many feet that is, or 500, let's see how many miles that is. How about we do that? And so we start with what we know, 525 meters. Now I could use the quick conversion of there are 1609 roughly meters in 1 mile. We'll just use an approximation here. And so 1609 meters in a mile. That's a pretty good approximation. So how many miles is 525 meters? So you take 525 and divided by 1609. And you get 0.33 roughly. So we'll just say approximately 0.3. And so it's roughly a third of a mile. Okay, good. Now what I'd like to do is I like to do the same problem. And so 525 meters. And in each meter there are 100 centimeters. And there are 2.54 centimeters in an inch. And then there are 12 inches in a foot. And there are 5,280 feet in 1 mile. Okay, so 525 multiplied by 100 divided by 2.54 divided by 12 and divided by 5,280. And I get 0.326. Pretty much the same answer that we had before. 0.3 roughly miles. You see, either one of these conversion factors, either one of these methods of solving the problem will get you the answer. So if you forget that there are 1609 meters in a mile and you're having a difficult time converting from the length in the metric system to a length in the English system, this one right here, 2.54 centimeters in an inch, that's a good one to remember, because most of us, I think, learned that there were 5,280 feet in a mile and 12 inches in a foot, and we can pretty much study the metric system and figure out that yes, there's 100 centimeters in a meter, but that conversion from English to metric, 2.54 centimeters per inch is what you need. Memorizing 1609, that really is just of a convenience rather than a necessity. This one right here is more of a necessity because you could always go back in and figure out what this is, but you need that 2.54 centimeters in an inch. So don't forget that one. That's a big one. Enjoy your day.